Hey, what is going on, guys? Thank you for joining me today. Today we're going to be talking about reserved words and data types. So I actually made a PowerPoint, and that's what we're going to start off with, and then we're going to jump into the C program and kind of go off of there. So let's jump right in. All right, so what are reserved words? So in a nutshell, reserved words are predefined. They have a special meaning to the compiler, and they cannot be used as an identifier. And so over here to the right, I have the complete list of all the reserved words or keywords in the C programming language. So with that being said, reserved words, just know that you cannot use them as variable names as they're unique to the compiler, and these are more so tools for you to express what you want to write in your code. So let's move on down to basic data types. Now these are the very basic fundamental data types that you should know and learn. You have int, otherwise known as an integer. We have a float, otherwise known as a floating point decimal number. Double, same thing, but I'll discuss the differences in a moment. And then we have char. Char, short for character. Characters such as A, B, C, D, and all that nice stuff. Or characters such as the exclamation mark, parentheses, basically your standard keyboard input. And I mentioned it in the previous videos, like your ASCII character table. So yeah, so what are integers? So integers are basically whole numbers, either positive, negative, or zero. Very important. No decimals. These are just whole numbers. So 1, 2, 3, 4, all the way to infinity. -0, -1, -2, -2, all the way down to negative infinity. Okay, very important concept right here. Get this in your head that 1 byte is 8 bits. So 4 bytes is 32 bits. 4 times 8, 32. Okay, so that means, if you recall from the previous video, we can only have ones and zeros in the computer. Okay, so that's two different possibilities, and that's where we get the 2 to the power of 32. Okay, and this gives you the range, the maximum numbers in which an integer can hold, which range from negative 214,748,3648 all the way to positive 214,748,3647. Okay, so just keep that concept in the back of your mind. If one day you try to do a really large addition, really large multiplication, and you're getting errors, it's because the integer cannot hold a value that big. And if y'all are interested, I can actually explain in more detail, kind of draw it out so you can understand how the bits and bytes and all that fun math. But anyways, so a float and a double. What is the key difference? The key difference here is the size. A float is 4 bytes. Okay, if you recall, 4 bytes, 32 bits. Now a double, just double that. Double the 4 bytes, so you got 8 bytes. But these can hold real numbers. So what are real numbers? Okay, if you don't want to get too technical, just imagine floats, doubles, just decimal points. So if you're doing 2.7589, so on and so forth, that's what I'm referring to as real numbers. And they can also hold 1.0, 2.0, all that stuff. So chars, characters, size of a character is 1 byte, and we already discussed what characters could be as we refer to the ASCII table. And over here, as you can see, I've probably used right here %D, %C, %F, and %LF. And then these are basically the format specifiers, because whenever you want to print stuff to the console, you need to specify the data type in which you're wanting to output. Okay, so that's just a little reference chart I put in there. And we're actually going to jump into the code real quick, and we're going to discuss these basic data types, and then we're going to move on to more data types, but we'll come back to this shortly. So let's get into the code. All right, so over here I predefined an int, a float, a double, and a char. Okay, and I just follow the format A, B, C, D. Again, you can name these whatever you want. These are variables, your identifiers, just as long as they fall within the rules. And please refer to video 1 or look up identifiers in C to refresh yourself on the rules. So over here, what do I want to discuss about these data types? So just as proof of concept, I'm going to go over here and I'm going to uncomment this. And again, printf, I just want print to the console. and I'm just doing two new lines. Two new lines, think of it as enter and enter. Okay, just a format, not really important for this, but let's break this down again. So we got printf, we have quotation marks because that is, we're encapsulating our string, our message within this, okay? Over here, our %lu, we have not discussed that yet, but just know that it is a type of format specifier. And since I am using, this is a function now. So actually, yes, it is a function. Size of A. What is the size of A? Okay, we can kind of use this. Size of int, size of float, size of double, and all that. So LU, right now, just don't worry about it. Just don't worry about it. But do recall, we'll touch up on the ones I mentioned, %D, %F, LF, and %C. So let's go over here and save it. And just as a reminder, we're going to save over here, and we're going to do GCC, okay? And then we're going to do practice.c or whatever your C file is called. We're going to hit enter. And then if we ls, we're going to get a.out executable. So we're going to go /a.out and enter. So let's break this down. So if you recall, size of an integer, 4 bytes. And although I should have put it down in the message as bytes, but integer is 4 bytes. A float is 4 bytes. Double is double that of a float, so 8 bytes. Yeah. And a character, char, is 1 byte, or otherwise known as 8 bits. Okay, so 8, either 1, 1, 0, 1, 0, 1, 0, however 8, until you get 8 different combinations of ones and zeros. Okay, so that's just kind of proof of concept of what I was mentioning in the slides. So moving along, let's go back to the slides. All right, so more data types. Now, I want to just mention this because I know I know you might see it, you might have seen it before, void. So what is void? And I know that for some it could be a little bit complicated to understand, but just know that void, just like any other data type, okay, just like anything, it's stored in your machine. Okay, so get this idea in your head. It's, at the end of the day, everything is just memory in your computer. So void, what is void? Void is basically incomplete type, nothing, or no type. Okay, and now try to grasp your mind around this. So it's not an int, it's not a char, it's just there. Okay, it just exists. Now don't worry about it too much, but just keep that in mind. And we're going to be using this whenever we want to return nothing. If you want a function to, let's say, just print out hello 100,000 times, you might want to do a for loop, I iterate through 100, print hello world or hello, whatever, and all that stuff. But you don't want to return anything. You don't want your function to pump something out. So you would use something like a void return type, as opposed to if you have a function and you feed it a simple addition function. So you have a plus b equals c, and you want to return c, the output of the function. But again, just keep these thoughts behind in the back of your head. We'll discuss functions later on in depth and go from there. But to continue, we have also short and we have long. So very simple concept. When you need to use store small numbers, I'm sorry, I think I worded it wrong. But when you need to use store large numbers, okay? Okay, no, I guess that does make sense. Yeah. So what is this? What does that mean? Basically, it's an extension of the integer, it's basically an extension of the data type you want, okay? So we're actually going to jump back into the code, so let's do that. All right, so we're going to go back, and I'm actually going to comment this out just so we don't see it anymore. And we're going to come over here. We're going to go into more data types, void star, just proof of concept that it works, void. We're going to do GCC a.out, and we get no errors and it's able to compile. So I just want to show you that just so you can see it. Don't worry about it. I'm just showing you. Don't worry about it yet. We'll get to it. We'll get to what the star is. Just be patient. So let's go over here. We have a short int, short integer, long integer. And now I want to ask, over here to the right, I have the size of an int, the size of a float, size of a double, size of a char, okay? Right now we're assigning an integer, but we're adding short and we're also adding long, okay? So what do you think is going to happen? What do you think the size of bytes, how do you think it's going to get affected? So I'll give you a little second, or pause it and think about it. But I'm going to answer this question right now, and I'm going to uncomment these right here. You can follow along. These are the same format as I did the ones on top. I'm calling size of, okay? Size of small. What is small? Small has no value attached to it. No value attached. And that's something I want to make clear. Right now I am declaring a variable small with the type integer, but it's also short. Okay? No value set to it. It's just declaring it. I'm letting the computer know that I have a variable of this size and I might want to use it in the future. So let's go over here and save. Let's do GCC. Let's do a.out. And now let's see what the difference is. So size of a short integer is 2. And you're probably wondering, well, Jonathan, you just said that an integer is 4 bytes. Why is it 2? Well, that is what the point short is. You have limited amount of memory, okay? So if you're gonna store, let's say, values of the range, some numbers that fit into 8 bytes. What is that? No, 16 bytes. Okay, so that's 2 bytes, so 16 bits. Okay, so it's not as big. It's basically half the size of your 32-bit integer number. So why would we want to do this? Well, if you want to save memory, right? So you're not using the extra bytes, and that's where this concept can be used to save memory in a sense. But for a long, let's say you need to use a bigger number, so you would want to assign your value of long. And now this concept can apply to floats and decimals. So just keep that in mind. And I don't think it can be used in chars. Actually, it cannot be used in chars characters. You will get an error. So the most important concept I want to get out of this video, we're actually going to have to jump back into the slides and we're going to finish off there. So let's do that. Okay, so last thing I want to talk about is data modifiers. So I'm actually going to read these out for you. These are used to alter the data storage of the data you are using. So we saw short, we saw long, we saw basic data types. We have an integer, you want to store numbers, floats, decimals when you want to store real numbers. Okay, we have characters when you want to store characters. And so now we come up to this concept of signed and unsigned. So signed value can be both positive and negative. Okay, so here I'm going to give the example of a signed short. So if you recall, a short int can only go up to 16 bits. Okay? Okay? I'm actually going to show you right here. Keep this number in mind. Okay, 65,535. 65,536. What number is right here? 65,535. Okay, key difference. Number starts at 0. Okay, remember that. And see, we start at 0. Okay, so that's why we are offset by 1 over here and offset by 1 there. Okay. Again, if you have any questions, just leave them in the comments. I do not mind replying to them as long as I understand what the question is and I can answer it appropriately. So yes, so back to this topic. So we have a value. When it's unsigned, it means that that value can only go up to 65,535. Okay? But let's say we have a short integer. Okay? So using this concept, we can hold the biggest number we can hold is 65,535. If we jump to the code, so I'll move this to the side. If we jump over here to the code, and I'm going to do this one with y'all. So we're going to get a variable called, we're going to do a short, we're going to do an int, and we're going to call this x. And we're going to set it to nothing right now, and we want to print the value stored within x. So we're going to do printf, okay? And we're going to say the value equals, and we're going to do %d. We're going to do our format specifier, %d. Go back here and show you. Int %d or %i. Come back over here. We're going to do comma because we want to, which variable do we want to print? We want to print x. So we're going to set this equal to something small, like 10. Okay. We're going to go over here. We're going to clear this out. And we're going to do GCC. And I forgot my semicolon. And again, semicolon is just the format of C. You're going to have to do that at the end of every expression you do. So let's run that. And we get the value 10. And I'm going to make this a little bit prettier. Just like that. So we get the value of 10. So now what happens if we go over here and we increase the value by 100? We make it 100. Let's go over here. Let's do GCC. Still no errors. Now let's raise it up to 1,000. Save. GCC. No errors. But now let's go to 10,000. Okay. We're going to do GCC. Again, nothing. Why? Because we are still in range of our 65,535. But before I jump into getting so big, now what we're going to do is we're going to make it either unsigned or signed. Okay? Okay. So let's do unsigned. Unsigned short int. Let's go ahead and save this. GCC. Again, expected output. But now let's jump to 100,000 and see what that produces. What do you know? Implicit conversion from int to unsigned short changes value from 100,000 to 34,464. Let's do some quick math. Copy and paste that value. Subtract. What do we get? 65,536. 65,536. Okay, so are you starting to see what I'm saying? Okay, it means that we are out of range because it is unsigned. It's unsigned. We can only go up to 65,535. Okay, but now more interesting concept, which is with a signed short. Signed means that it can be both positive and negative. But whenever you can be both positive and negative, you could have overflow. When you go from 0, you can only go to half of that, 32,767. And if you go above that, you're going to start going into negative numbers because it's sort of split. And this is a good example. It kind of shows you blue and red. But I always think looking at it is way better than seeing it. So let's do signed. And now we're actually going to do 3,000 first. Okay, because we can only go up to 32,767. So let's go over here and save this. And we should not get any errors, any warnings. We didn't get any warnings or errors. So that's great. And now let's do 30,000. Let's do GCC. Now let's do 35,006 GCC. and now we get a warning. And now if you noticed, we've gotten warnings. Okay, they're not errors. Okay, so now let's see what happens whenever I actually compile it. Well, I get a negative number. Okay, because we're now in overflow. We went past 32,000. You can see right there. Now we're into 30,000, negative 30,000. So we're probably somewhere over here. Okay. So I'm going to show you that same concept with the unsigned. Make it 300,000. GCC, we get the same warning. And now we have a stop at 22,320. Okay. It's not the value we put in. It's not. So yeah, you can see why it's important to know these things, because if you're doing math, if you're doing multiplication, addition, subtraction, division, any of that stuff in the future, you're gonna need to know these depending on your application, because then you're getting weird numbers. You're like, why am I getting these numbers? Well, this could be a reason. So I think this is a really great stopping point. I hope you guys enjoyed this video. Appreciate the support, and I will see you guys next time. Thank you.